Today on Paul's Old Crap, we're going to replace the capacitors on the power supply from a Macintosh IIsi. Now, this particular power supply is currently non-functioning, and by replacing the capacitors, I'm hoping we can bring it back to life. And I guess at the end of the video, we'll find out if we're successful or not. So the actual casing comes apart pretty easily. You start off by removing one screw up there. This causes the lid to come off. And then inside the unit, there's, I think, another screw at the bottom you remove, and then you unplug this connector here. Then this whole assembly comes out. And then you've just got 3 screws that you remove, and then the entire board. I kind of had to slide it out this way while keeping it around this level in the board. It gets a little annoying because there's little like tabs here that kind of prevent it from going directly up unless you were to like really bend the metal outward, and didn't really want to do that. So yeah, but it wasn't too bad. I think the LC power supplies are easier to deal with than this one, so it's still not the most complicated power supply to remove though, so not too bad. But what we're going to do is I'll be going over all of the capacitors in here, and there's one difference between this and the LC boards that we did on the last video. The power on circuit. This is something that the LC power supply does not have because it has a physical switch. The IIsi does not have a physical switch on the power supply. It has this board here which controls when the power supply will turn on and off. And I think this is actually the failure point on this particular power supply. And it's a kind of annoying because there are these service mount capacitors on this board, and those have to be replaced because I think they have actually already leaked out onto the board. So that is more than likely the reason why this power supply does not turn on. Otherwise, the board does look in decent shape. There's another power supply I was looking at that had massive leakage out of these capacitors here. These are the so-called long life capacitors, because it says long life on there, but these are the ones that are absolutely the worst. I think there is some leakage coming out of these ones already, and definitely when you're doing recapping on these, you want to get these out of here because these will cause a lot of damage to your board if they continue to leak. So yeah, these ones aren't too bad, but as we pull them, we'll find out just how much leakage there's been. So what I'm going to do is I'm going to get started, and we're going to first pull these 2 big capacitors out. So when it comes to removing the capacitors, I just use this desoldering wick braid stuff. I suppose you could use like a solder sucker, but this was, I don't know, the cheaper way that I saw. So we just heat up the solder, and the braid should absorb it all as it melts. Some of this old solder doesn't come off as smoothly as I'd prefer. I think that one is okay. Oh, I think the capacitor actually just fell out the bottom. Let's take a look here. Yes, here we go. Now these, they don't look too bad. It's the internal chemistry that I think breaks down over time, so I don't think there's actually any leakage out of the bottom of this capacitor. And if we look at where the capacitor came out of, what you're seeing on there is not capacitor leakage as far as I know. That's just kind of part of the manufacture process, I believe, because you see that same residue on like all of these other components, and when you look at the underside of the board, I think it's like dried flux or something from the manufacturing process. So on this particular capacitor, there's nothing we need to actually clean. It looks like it's good for the replacement. And when we look at the indications on the board, the positive is on the upside here, the negative is down there. So when we take our replacement capacitor, we make sure the negative side is that way, and we line up that, drop it in place. I'm going to hold this with my finger, and what I do is I just kind of bend these pins out of the way because I don't actually do my soldering until the very end. So when we take a look, we see that our new capacitor is in place, and it is slightly smaller physically than the old one there, but as long as the specs line up, you should be fine. So what I'm going to do is I will continue and pull the other one out. Okay, so we've got our second of the large capacitors reinstalled there, and what we're going to do now is, I think we're going to pull one of these big capacitors out here. These are the ones that, like I mentioned earlier, are very much prone to leakage and failure, so let's get that out of there. Take our desolder braid. Kind of a pain to try and do this while keeping my hand out of the way of the camera. I think that's probably good enough. What I sometimes do with capacitors, especially if I'm worried about it being dirty and stuff, I'll just use pliers to actually pull the cap. Well, that actually came out pretty easily. There is leakage on the bottom of this capacitor, and you can see there is a bunch of gunk that's on the board. So this definitely is a failing capacitor, and if we let that sit like that for too much longer, it was bound to cause additional failures on this power supply. Some of the boards I've been recapping, there's already been leakage on working power supplies, and as it continues to leak, it then bridges the connection on the capacitor, and then obviously the power supply no longer works. So what I'm going to do is try and clean that up a bit. So for cleaning, I use Q-tips, and I've put some isopropyl alcohol on the end of this one. So what we're going to do is, so you can see it in there, just kind of clean some of that crap off. And as you can see, that is clearly dirty. It's very gross. So it's, because the leakage wasn't too bad, I think that is actually all we really need to do for cleaning. If your power supply has a lot of leakage, what'll happen is it will leak through the holes and then all over the bottom of the board. I've seen that before on these particular power supplies, and it was eating away at the the underside of the board. Like this green stuff was flaking off the board. So yeah, it can get pretty messy. But underneath on the bottom of the board here, it looks fine on this one, so we don't have to worry about that. All we need to do is drop in the replacement capacitor. And if we look at the old one is a 2200 and 6.3. You can see it there, I don't know. So then we go and find, that's a 1200, our replacement capacitor, 2200 6.3, that is correct. And if we look at the board, it says the positive is down and the negative is that way. So we angle the capacitor, so that is correct. And then, whoops, underneath here, I'm just going to bend this out of the way until it's time to actually do the soldering. So that's Not too bad. And what I will do is I'll proceed to get the rest of these capacitors out. One thing I will note, there was a lot of glue that was on here that I removed prior to starting the video. It's basically to hold the capacitors in place, and it was covering like a bunch of these other components in here, so what I did is I just took pliers and carefully pulled all the glue out, and trying not to destroy any of these other components that are in here. I think everything else should be okay. So yeah, what I'll do is I'll just go ahead and replace the rest of these capacitors, and then we'll talk about the power on circuit board there. Alright, so we've got all the capacitors replaced, and I've just basically got all of the leads bent outward in preparation for the soldering. What we need to do though is we need to remove the power on circuit board from the base of the power supply. Now, if you're feeling really adventurous, you probably could get these capacitors off without removing the board. One of these that I recapped, I did exactly that because there wasn't a whole bunch of leakage. I just wanted to get the caps off and replace them without needing to clean the board. But on this one, because I believe this is one of the reasons why the power supply doesn't work, I am going to remove this from the power supply and give it a good cleaning. So it's kind of annoying, but it's not all that bad. We have to desolder all the pins right here. So we will just take the desolder braid, and we're running this on pretty much the hottest temperature on the iron. And I think that is mostly done. What I will need to do is just on the other side of these pins, I believe. There we go. And it has actually now fallen out of the bottom. So that indicates we didn't do too bad. So on the power on board here, we do have two of these capacitors here. Now, what a lot of people I think do is they replace them with the tantalum capacitors or the exact same style of capacitor here. But I'll just be using these radial capacitors because these things are dirt cheap, and I don't want to spend like $1 per capacitor on this little component here when it really doesn't matter what it looks like. If it functions exactly the same, I think I will use the cheapest capacitor possible. Now, when it comes to actually removing these capacitors from the board, the way I do this is probably not the way anyone would ever recommend you do this. I actually use pliers to rock the capacitor back and forth until the legs kind of break off. And generally, because these leak, they weaken the legs, I think, through corrosion. So it doesn't make this as bad as it may look. Although anyone who does this sort of thing for a living is probably going to see this and go, no, don't do that. But I don't have the proper equipment or the patience to try and do this properly, where you'd use probably 2 soldering irons at the same time with very fine tips and try to melt the solder from underneath the capacitor. But that is unfortunately not going to happen in my case. Another way I've seen people do this is by twisting the capacitor so the legs break. But I've generally had pretty good luck just by doing this. And I also just kind of push down at the same time so I'm not pulling upward on the board. I heard, I think, one break there. Oh, they both broke. So underneath we do have some signs of corrosion. You can see that on the bottom of the capacitor there. And if we take a look at the board, it is a little bit dirty under there. So what I'm going to do is I'm going to remove the other capacitor, and then I'm going to try and clean this as much as possible because I think there is some signs of corrosion on the surrounding components. And then we will go ahead and solder some new capacitors on. I tried to do the best I could here with getting it cleaned up, but the corrosion does concern me a little bit. It's chipped away at some of the green coating on the board in a few places there. I'm hoping this still works when we put it together, so what I will do is basically just put some of my gel flux down onto the pads. And we will put a little bit of solder. Now this is going to be tricky because it's such a small component. I don't know if I can show this on the camera without my hand being in the way, but so what I've done is dropped a little bit of solder in there, and we can use that to get the capacitor in place. Let's see. Now this is also going to be tricky because I have to try and, well, I think basically you just won't be able to actually see as I solder this in because it's unfortunately such a small component. So give me 1 sec as I do this. Okay. So I think that should probably be fine. Looks like I think the joint looks fine. And then what I will do is just kind of gently bend this down so that we don't have any issue with the fit when we reinstall this back into the power supply. Okay, so what I will do is I will go ahead and solder the second capacitor on there, and then we'll go ahead and get this back inside the power supply. Alright, so we've got the power on circuit back into the power supply, and what I'm doing is I've just got this little container down here to prop it upward and try to keep it in place. And then we will put a bunch of the flux down on the pads here. I think that should be fine. And now, see if we can drop some solder. My hand is kind of shaking a little bit from the very awkward position of the iron, so this is kind of annoying. Alright, and let's take a look at the work. So there's a bunch of flux on there, so it might not be as clean looking, but I think we do have a decent amount of solder on all of those pins. Yeah, I think that should do the job. Alright, so now that that's back in place, what I'm going to do is probably just do, well, I suppose what I should do is solder all the rest of the connections in there, and when I'm finished with that, I will clean off the board and then we can reassemble it. Alright, so we've finished the soldering and we've got all of the those leads clipped off. Bottom of the board does not look too bad. I don't think I'm going to try and do any serious cleaning on here. I don't think there was any capacitor leakage that was really getting to the bottom. Otherwise, I would do a full clean, and probably with vinegar or something too, to counter the, I think the chemical of the capacitor leakage or something like that. But I think it looks fine to install, so we will take the bottom piece of our board here. And the way this goes back in, it's kind of annoying, but yeah. Basically, it just slides through the rest of the way. Not too bad. It's the initial part of getting it into the metal that seems to be the biggest pain. And when you've got the plug on the bottom, I think what I'm going to do here is just basically grab it with pliers until you hear these parts snap into place. And we have everything else that should line up. So if we seems to be reassembling decently. Third screw is kind of a pain to get to because these cables are in the way, but then we've got, there's one thing that's in here, I probably should have put this in there beforehand, but there's a component that has some thermal paste against the metal in here, although I don't know if I'll be able to get to it. Trying to get this stuff to actually stick into this one particular spot in here. Alright, using the knife I think seemed to do the job. Just want to get some thermal paste in between that component and the case. So when we put, let's see, it's this piece here, it pushes that component right back into the side of the case. These things are so much fun to reassemble. And we'll tighten up that component, that screw rather. Should secure that. And I think the, thermal compound is coming out the sides, so it looks like we got quite a bit in there, should be fine. And this last piece, which I don't actually know what this thing is, it just attaches into the side of the case. That should be fine, so that is secured. And now we will take the plug piece. So this connector just plugs into the board, and this piece just kind of, well, it basically just fits nicely in that spot. And then we will take the lid and so that snaps in. There's 2 screws left that hold the lid down and also secure the plugs. So we will put the top screw in there. Come on. Alright, and on the bottom, and this lines up with the bottom part of the plug assembly. Alright, so we are ready to test this out in our IIsi. Alright, so we've got a IIsi here. And the power supply, just to note, I have not actually tested this yet, so I'm really hoping this does actually work. The way this goes in, the plug side goes on here, pretty straightforward. Basically just line it up, and it drops into place. Alright, so we take our power cable, plug that right into the back, and moment of truth. Wow, it actually works. So we were able to successfully revive this power supply by doing a full recap. Just going to hold in the power button to make it turn off. Unfortunately, that is not working. Strange. So I've just physically unplugged it. Now what I want to try doing is plugging power in again, making sure it doesn't automatically turn on, and then there we go. So typically, if I've seen some of these computers where if you apply power and it turns on just by itself, that might be a fault in the logic board capacitors or the power on board in the power supply. So the fact that it does nothing when we apply power, but it turns on when we flip the or push the switch, which is a motherboard switch, not a power supply switch, that indicates, well, I believe that indicates that the power on board inside the power supply is working correctly now. So, ultimately, we did have a successful recapping of the power supply, and I'm very glad that worked out. So, yeah, and I figure I might as well also mention that, of course, I am not a professional at this, I'm just a hobbyist, so some of the methods that I was using for soldering and whatnot, there's probably better ways to do it. If you're interested in doing this work yourself, I recommend that you look up proper instructions from professionals on how to do soldering work. But yeah, I'm glad this worked out for my case anyway, so thanks for watching.